Hello, this is Nirmala Shenoy presenting our research project on rethinking the Internet for defense communications. Looking at the communications and protocol challenges faced by the Internet today, currently we use the Internet protocol and all our communications are Internet protocol based. We use OSPF, Open Shortest Path First, for intra-AS routing and Border Gateway Protocol for inter-AS routing. IP, OSPF, and BGP were designed for networks and technologies 30 years ago and are retrofitted to address current and evolving communication needs. These protocols, hence, are highly complex. They are difficult to manage. They have a high level of configuration need with the possibility of human error, are vulnerable to security threats, and incur high energy and equipment costs because of the complexity. Securing highly sensitive defense subnets can be working out very costly for defense networks. Retrofitted IP, OSPF, and BGP is the current state of the technology, current state of the art technology to support communications today. What are the limitations? OSPF is used for intra-AS routing. BGP is used for inter-AS routing. The networks running these protocols face very slow convergence, and that takes a long time for the routing tables to stabilize. There are quick fixes, but even that is going to add to the complexity and probably the instability. Border gateways are highly complex because they run OSPF, IBGP, and EBGP, and it makes them much more vulnerable to attacks. What does advancing state of the art look like? What can we do about it? We can replace IP, OSPF, and BGP with a single simple protocol. We call it the Expedited Internet Bypass Protocol. The protocol stack is shown at the corner there. It is a very simple protocol. It simplifies intra-AS routing extremely and can also simplify inter-AS routing. We can introduce customized security and nested network security for highly sensitive defense subnets. What is there in this design of EIBP? EIBP just uses structures in the network, else overlay a structure and use that to assign routable addresses, auto-assign routable addresses. And EIBP uses these addresses to route the packets between IP end devices and networks. It's backward compatible with IPv4, v6, and the Ethernet. Let us show you a simple example of how this works. This is a common three-tier structure you see in our networks: core routers, distribution routers, and access routers. We just assign a unique ID to the core routers, and the rest of it is done by EIBP. Distribution routers will get addresses assigned by core routers, and access routers will get addresses assigned by distribution routers, and the routes are all set up because all these addresses carry positional information. EIBP can also be extended to route between autonomous systems. What is the significance of this invention? We'll present it with a few results. Okay. Here is a comparison of EIBP with OSPF. Look at the very, very low convergence time you face with EIBP. How about the control overhead that gets generated on an interface failure? Again, EIBP has such low overhead that reduces any eating up of the bandwidth. And here is some packet loss statistics, and even that is very low. The team, Dr. Nirmala Shenoy and Professor Bill Stackpole, have been working on such innovative protocol projects for quite a few years. Bill Stackpole is the security expert in networks, and Nirmala Shenoy comes up with these innovative ideas. Professor Shenoy also supervises PhD and graduate students. She has received several grants. This project was funded by an NSF seed grant. Professor Stackpole was instrumental in starting the Cybersecurity Institute at RIT. So, how does this solution impact the defense and commercial market? This novel design in the interim is backward compatible with IP and Ethernet. Network operations are extremely simplified, performance is extremely improved, several magnitude. This will cut down on the configuration needs and human errors. Reduced hardware, software, memory needs will have a major impact not only on the cost, but the energy and carbon footprint and the global warming due to the IT industry. Continuing with the benefits, troubleshooting networks is a very, very significant challenge. This solution will simplify that. And like I said, you have the reduced maintenance and management effort, reduced costs. Networks without IP, BGP, OSPF, we mitigate any IP targeted attacks. We can customize and design nested security for defense networks. These solutions can be easily extended into the commercial market. And this approach is like an example of forerunner for everybody to come up with novel solutions rather than use retrofitted protocols, which is complicating communications and the IT industry significantly. Thank you. Bye.